morning, students. We are studying Science 1, chapter number 6, Refraction of Light. These are the points that we are going to cover up in detail. But let us see the basic about reflection of light that you have studied in the previous standard. See the object, this is the mirror, and when the ray of light has been incident on it, it is called as incident ray, and after incident from this point it is getting reflected back, so it is called as reflected ray. And this is the normal which is being drawn at the 90 degree. So this will be the angle of incident I, and this is the angle of reflection R. In the down picture also it has been shown that the ray of light which is coming from the torch fall on this plate and gets reflected back into the eye, so you are able to see the object. Similarly, if you have been kept in a dark room, you will not be able to see anything, but if you place a torch light on any object, that light will fall on the object, and from that object the light will get distributed in different direction, and that light will enter into your eyes and you will be able to see that object. So when light is incident on the surface of an object, in general it is deflected in different direction. This process is called reflection of light. Now let us study what is refraction of light. Here the activity is being shown. Take the first activity. Take a glass of water half filled and place the stick or pencil inside that. At this point what you can see that it has been broken, but it's not the broken. It has been appearing to be broken. Even you can see the thickness of both. This is much thicker than that of this. Even now take this second. The coin is being placed here, but when you see from this angle, it appears to be here. The next is this. You place the arrow, it has been shown here, but you can see how it's been looking when you see through the water which is placed inside the glass. The direction also change, even the thickness is been increased. So this all is due to the refraction of light. These are some daily examples that you must have seen in your life. Light changes its direction while going from one transparent medium to another transparent medium. This is called refraction of light. It is very important that the light changes its direction when going from one transparent medium to the another transparent medium. Let us see with this one activity. This is the glass slab. Okay, take a piece of paper and place this glass slab on it, and afterwards draw the outline of that and then remove the glass slab. Take a point here with the protractor 90 degree and make an angle 30 degree from that. Okay, after placing that, again place the glass slab on the paper where the boundaries that you have been drawn. Then put two pins on this line where you have taken that 30 degree angle, and from this side see that the two pins are in a straight line. Then you have to put two more pins here in such a way that this 1, 2, 3, 4 all the pins are in a straight line. So you will do that. After doing, you will remove the glass slab and then you will join these lines, and from your point you can draw the normal with the help of protractor. So what you can see here, this is the medium, which is air. When light passes from air, that is the rarer medium, and this is the glass, which is the denser medium. It changes its direction. You can see here. Even while going from denser medium, that is glass, to air, again light changes its direction. So it's been clear from this experiment that light changes its direction when it goes from one transparent medium to the another transparent medium. If this glass slab must not have been placed here, then what must have been happened is the ray of light have passed in this direction directly. But you have placed the glass slab here, that's why the ray of light from this point it get refracted, and from this point it again gets refracted. So it changes its direction, that you can see from the picture clearly. Here they have shown here. This changes its direction, and again here also it changes its direction. Here they have done for 30-degree angle. You can do it for 60 and 90-degree angle. So let us see the laws of refraction. The incident ray and refracted ray are on the opposite side of the normal to the surface at the point of incidence, and all the three incident ray, refracted ray and the normal are in the same plane. You can see this incident ray and this is the refracted ray lie on the opposite side of this normal, and all the three rays are in same plane. Next is the Snell was a scientist who has given this law, Snell's law, that is sin I upon sin R is equals to constant, which has been given by N. These are the two main important laws of refraction. Now let us see the next topic, refractive index. The change in the direction of a light ray while entering different media is different. It is related to the refractive index of the medium. The value of the refractive index is different for different media and also for light of different colors for the same medium. The refractive index of a medium with respect to vacuum is called the absolute refractive index. The refractive index depends on the velocity of light in the medium. This is important. It depends upon the velocity of the light in that medium. You can see here the light rays passing. Here they have taken velocity v1. This is the medium 2. They have taken the light which is being refracted through this point, that is v2. The refractive index, it's been written as in this symbol, which means that the refractive index of second medium with respect to the first medium is written in this way, which is equals to the velocity of light in medium 1, that is v1, divided by the velocity of light in medium 2, that is v2. See this. Here it is being shown the refractive index of second medium with respect to the first, and here the refractive index of first medium with respect to the second. It's been shown in this way. This is the diagram for that. Why air is always been taken as a rarer medium? Because its refractive index is 1. Here the table is been given for different substances and the refractive index. The refractive index which is less is always been taken as the rarer medium, and the refractive index which is more is always taken as the denser medium. So you have to remember for air and water what is the refractive index. If the first medium is vacuum, then the refractive index of the medium 2 is also called absolute refractive index, and it is written as N, the symbol given for that. When a light ray passes from a rarer medium to a denser medium, it bends towards the normal. See, this is the normal and this is rarer medium and this is denser medium. It bend towards the normal. When a light ray passes from a denser medium to a rarer medium, it bends away from the normal. See, this is the normal and the light ray passes from denser medium to rarer medium. It bends away from the normal. When a light ray is incident normally at the boundary between the two media, it does not change its direction and hence it does not get refracted. You can see here, there is no change in direction. So these 3 points are also important.